Well, that went better that time. I need to have my morning coffee. Good morning, my name is Gary, and today I'm going to talk about my metal shapers. This is my first shaper. It's an Atlas Model 7. And most Atlas shapers are the later Model 7B, and what they did on the 7B is they extended the foot and put a front table support because they found that on the Model 7 there was a little more deflection than what was desirable. I have the older model, and I have it set up to do a cut right now. There's nothing special about what I'm making. I'm just basically checking to see what kind of finish I can get and whether I have the tool bit sharpened or not. So I've just got a block of 12L14 in there, and we're just going to do a quick cut. So I'm going to put on some eye protection, put on some hearing protection, and let's start the cut. That is not a bad cut. As you can see, that is a very smooth cut. If I run a finger across it, I don't feel any ridges in either direction. Fingernail, I can slightly detect them. That's quite satisfactory. 9 days after I purchased the Atlas shaper on eBay, and I got it for, as I recall, somewhere around $500 back in the spring of 2005. 9 days later, I saw another one. This is my 20-inch G&E. Acquired this for $200. Same day I had the opportunity to get two more large shapers, and for a while I thought I was going to get those, but as it turned out, I wasn't able to transport them in time. We ended up giving those to somebody else. So this machine is an industrial capacity machine. It is a 20-inch shaper. As you saw from the quick run on the Atlas, shaper has a reciprocating ram and a table that moves perpendicular to the ram. So it's primarily used to plane flat surfaces. The tool slide can also move the tool head up and down, and this can pivot. We'll show that in a bit, but it will allow you to do dovetails. It will allow you to do vertical cuts. Some shapers have power feed on the down feed. Mine does not. Some shapers have automatic tool lifters on the clapper box. This one does not. Never found a need for that. I actually have this set up right now for a job, although it's not set up the way I want to cut this job. We will run with it in a little bit. But the first thing I want to say is a little bit about safety with this shaper. The ram moves back and forth with a lot of force. This shaper has a 7.5 horsepower motor on it. If you were to take a typical cutting speed of, say, 55 feet per minute, 1 horsepower is 33,000 feet per minute. Divide that out. It's about 600 pounds of force per horsepower. 7.5 horsepower motor, that works out to about 4,500 pounds of force. Now, before somebody tells me that there's inefficiencies in the machine and you're not getting that, you might not be cutting at that speed. The important thing is 1-2 tons of force here. You get your hand in your finger, your arm, it's not going to stop this. And one of the things that I did early on was I managed to break a tool bit. I've also managed at times, when I didn't have the vise tied down, to almost push the vise off the end of the table. So this is a machine I respect. Respect all the machines in the shop. This one, you'll see me operating it with one hand. When this tool bit broke, pieces flew out, hit me in the chest. I was standing back here behind it. And it didn't hit hard, it was as if somebody threw it. But eye protection is important. Be very careful anytime working and, for example, trying to get chips out of the way. It's not something that you want to get your hands in there to do. So you need to be very respectful of this machine. Your hands will not stop it. Most of the controls on this are on this side of the machine, so I'll bring you over here to take a look at them. Starting in the back, electric power coming in to a disconnect switch. This machine runs on 3-phase power. I make my own 3-phase using a rotary phase converter. So when we have the machine running, I'm going to have to start that up first. Moving up, this selects the number of strokes per minute on the ramp. That's not the cutting speed, it affects the cutting speed. But if you have a long stroke, for the same number of strokes per minute, the cutting speed will be proportionally higher. These calculations, you can very easily calculate that. I made a simple table with a spreadsheet and had this taped to the machine. Tape's kind of getting old, so I need to make a new table and tape it back up there. So I just use that as a quick reference. So for speed select, I can go anywhere on low speed from 15 strokes per minute up to 130. And there are 8 settings. There's 4 in low range. And this selects which of the 4. And then I have a high range and a low range selection up here. This is where you set the length of stroke. And to do that, just a matter of turning the handle, reading on the dial what the length of stroke should be. And you may have noticed that as I do set the length of stroke, it does have an effect on the ramp position. So when setting up, always select the length of stroke first. Good idea, I use about 2 inches longer than the actual length of cut so that I have clearance at each end. So 2.5 inches longer seems to work most of the time for me. This handle selects the feed rate if you're doing an automatic feed. It's on 0, and it goes in 10,000ths of an inch increments all the way up to 180 thousandths per cut. So if you're doing a roughing cut, a deep cut in steel, you're usually working on one of the smaller ends of the range. If you're doing a finishing cut with a shearing tool of steel, I take the minimum at 10 thousandths. But if you're doing a finishing cut with a flat nose tool with cast iron, you want to move up to the larger one so that you get the full width of the tool going across and the cut doesn't get very long. This is for automatic table traverse, high speed, table traverse engagement here. If you have it engaged this way for the table to move one direction, say towards us, the high speed will actually move it the opposite direction. Table traverse can also be done manually by the crank here. And this is another safety feature that or tip that I will give. This thing, when you engage the rapid traverse, you've got the handle in, it spins around quickly. I heard of somebody one time that slammed their knee with this. This is for manually raising or lowering the table. There's also a lever under here for doing it automatically. But before raising or lowering the table, you need to unclamp it. There's a nut here and one on the other side, but they very conveniently put a gear to control it over on this side. The reason I have the yellow tie wraps on and I have it down on this handle is to remind me that I need to loosen these before doing the power feed up or down. Also need to loosen the front table support. If you don't, you can do some damage to the machine. This is the on-off clutch for starting the motion of the ram. Electric on and off switches. There's several more controls up on top. This is a lock that locks the ram to the block that is controlled by a threaded rod and this crank to position the table. So if you want to position the table somewhere, loosen this. I use a pipe as a cheater bar, and then you can move the table to where you want the initial position to be. And then just pull it tight when we store the stripe right here. Remember what I said about this thing generating a couple tons of force? That adjustment rod in there will not take the force. So if you were to run the machine on a heavy cut without this being locked, the only thing controlling the ram would be that threaded rod. You'll bend it and basically have to go back in, turn the machine apart, and replace it. The gentleman that I bought this machine from made that mistake on one of his other shapers and replaced it right before I got this one. This control is for rotating the tool head, and right now I have it set on 90 degrees. There's a scale here. That's the place that I normally leave it. This moves the tool head up and down. I have the tool in a specific position right now and locked, so I'm not going to do that at the moment. The clapper should be tilted away from the work, so I have it tilted over this way, and that is so that on the return stroke the tool isn't dragging as much. It's kind of swinging out of the way, and this moves up. The tool, however, is vertical. As this cuts across, this tool wants to rotate this way, and if you don't have it in tight, and the tool, if it were like this, it would rotate down, dig into the work. Keeping it vertical, if it does rotate, it's going to come out of the work. So those are the basic controls on this side of the machine. What I have in here, I've got a block. All I want to do on this block is take about 3/8 of an inch off at the top. It's set up to do that. It's not set up the way I really want to do this cut. So I'm going to take a few strokes. I'm going to start the machine up. We're going to take a few strokes, and then I'm going to go and turn this around and set it up the way that I think it should be set up. So let me start the phase converter. Now if I wanted to, I could have just let this run, gone off and done something for a little while, and eventually the table would have moved past. I would have gotten the whole top surface cleaned up. Looking at the chips, they come off hot. These have a little bit of a straw color to them, so I'm probably just about the right speed. I could go a little bit faster. A lot of times the chips will come off, there'll be straw colored fall here, and because they're hot they will then oxidize and turn blue, and that's probably about the fastest speed I would want to push the machine to. The problem with letting the cut come across here is it's going to take a lot of time. Now, if you're just having fun or if you just want to watch it, that's okay, but a better idea would be to turn the work lengthwise, and that's what I'm going to do right now. This is a 20-inch shaper, and what that means is that there's a 20-inch stroke on the ram, and generally shapers, if the stroke of the ram is also the maximum, width and the maximum depth. So you should be able to, pick up a 20 by 20 by 20 inch cube of steel, mount it to the table, and then in a number of cuts just turn the entire thing into chips. Of course, there's never quite enough room to do all of that, so perhaps 16 by 16 by 16 is about the largest you could really do. And even so, that would still be kind of a heavy piece of steel to pick up with one hand. So I'm going to mount this lengthwise so I can do this whole surface. Now, this is just a rough cut. This is going to eventually be a spring tool for the lathe, so it's going to have some milling involved. It's going to have some other shaper work on it. We'll see what we do with it today. But right now I'm just going to tighten this up in the vise and then set it up for a long cut. With shapers, and just like milling machines, it's a good idea to seat the work with a dead blow hammer. The other thing that I can check on this is just make sure I've got the part vertical. Again, this is just a roughing cut before later machining. It's not critical, but it's good to get into that kind of habit. So now I should be able to cut this and see my layout line along here. I'm at the same depth I was before because it's resting on the bottom, and this way it should only take a few strokes to go across. Next, I need to adjust the length of stroke. My workpiece is about 8 inches long, so I want to set the stroke at about 10 or 10.5 inches. So, looking down at the stroke adjustment dial, my mark is here. And I'm at about 10.5 inches. You'll notice that by adjusting the stroke length, I have also changed the position of the ram. So what I need to do is loosen the top and put the ram about back where I want it to start. And so I want to have about an inch clearance here. That's going to allow the clapper to drop back down after the return stroke. Move the table out of the way. Let's start the phase converter. Put on my eye protection and ear protection. And let's check it and see how we line up. Stroke is good. Depth should be fine. I might as well get it close so it starts cutting right away. Okay, now the saw is still having the same number of strokes per minute as we had before, but the ram is moving a lot faster. So before I had 4 inches. Now I have 10, it's about 2.5 times the distance, so it should be moving about 2.5 times as fast. So I'm going to slow it down. Perhaps too slow. Go back to that. See how the chips look first. That was disappointing. The camera ran out of memory right before the cut started. So at this point in time, I owe you some more footage. I need to find another project where I have some long cuts with some significant depth, because I was getting some decent chips out of that. And I put up a shield to keep them from going all over the floor, but a few of them ended up down there, as you can occasionally hear from the sound of them falling. They make a nice ring. So, time to move on to the next step. Maybe it's about time to fix something that I've been putting up with for too long. If you look at the top of the jaws, there are some dings in them, some cuts and scrapes, and those are not a real problem. The only time I really need to have the tops of the jaws smooth is when I'm using the shaper gauge to set the height of the tool bit and setting it to a layout line on one side of the work and then going to the back, setting the tool bit back there. The bigger problem is that the front and back are not at the same height. And also, I'm not really sure that these are parallel with the table. In fact, the fact that they're almost aligned here and are completely off back here tells me that at least one of them is definitely off. So what I'd like to do is just take a nice light cut across this and get the tops of these straightened out. Now there's a couple ways to do it. I could turn the vise 90 degrees, cut longitudinally, but then I'd be worried about getting the table all lined up, making sure that I don't have a sag in it. I know that the table is level left to right on this, so I think the better thing to do is to just let the table feet go by and put up with the fact I'm going to be taking a lot of short strokes instead of a few long ones and go that way. Unfortunately, the tool I'd like to use is my finishing shear tool, and that's set up in the planer right now on another job, and I don't want to break that down and set it back up again. So I'm going to use a roughing tool bit. This one's a fairly sharp one. It's got a round nose on it, and my hope is by taking a fine feed and coming across here that I should be able to get a reasonably good finish. As I said, it doesn't have to be polished, doesn't have to be mirror smooth, it just has to be something that I can slide the shaper gauge along and get a nice smooth seat on it. So I'm going to set this up. Got a couple steps in the process. One thing I could consider doing, and I may do it if the first cut doesn't work out, is raising the table up a little bit, but I think that I can do this without too much overhang, particularly since I'm going to be taking very shallow cuts on this. The little bit of extra overhang, the rigidity of the tool slide, and the large bit should be fine. So it's just a matter of getting everything set up to the right depth and so forth. So to do this, it helps to have the shaper powered up to move things. So I'm going to fire up the phase converter, and then I'm going to move around, and the first thing I'm going to do is just get the tool bit out. Now I've got the tool bit out in the middle of the jaw. Shut the phase converter down for a moment so we can have a little bit of peace and quiet. Now I'm back here. So now I just want to decide what the depth of cut is. So I'm going to use the manual crank, move the table over, basically try to get that tool bit centered into the bottom of this one groove. As I said, I don't mind if I get a little bit of a groove going through this every once in a while, but I do want most of it to be basically smooth. So I think I've got it there, and I'm going to turn it down another maybe 0.010 of an inch. Okay, and lock the tool slide. I'll move the table over, and I've still got 3/16 of an inch clearance to the top of the vise. It's a pretty shallow cut. I should be okay right there. The other thing I'm going to want to do is adjust my length of stroke, and just putting a ruler on here, I've got maybe 1.5 inches across the jaws, so maybe a 3-inch to a 3.5-inch stroke will be about right. So set the stroke, and when I do that, obviously I lose my position on the ram. Because I just moved the ram out, I know it's not all the way at the back of the stroke, so I'm going to have to fire up the phase converter and finalize the position on this. But hopefully somewhere around there will be about right. So let's get ready to cut. Got my eyes and ears on. Now it's time to start to cut. And just maybe a little fast, but we'll just see how it goes. I have the feed set at 10 thousandths, which is the finest feed. Already I see the finish looks good. I like what's happening. So I'm leaving just a little trace of these grooves. clean it off and see what we have. Okay, I have a couple deep grooves here that didn't clean up here, here, and here. A little bit of a notch there. And it looks like at the very end I had a little bit of a hard spot. This is raised up a little bit, but I'm going to touch that up with a file. So I could see at the very end that this was bouncing a little bit. Another alternative would be to just back up and try going over there and just holding this down by hand, but it's such a small area I'm just going to file it down. So that looks good to me. Adjusting the tool bit height. This is going to be a rough cut, so I am merely eyeballing it. That ought to do. I have the mark along here to tell me a feet not to exceed. Mark the tool post in. My cutter so that it is vertical or has a slight lead angle to it. This is going to be a 90-degree corner. I'm not going to finish this cut on the shaper because I want to do most of the work on this project on the planer, just to demonstrate the planer. Make sure the work is seated. Use the square to make sure I'm square. I believe I'm ready, so I'm going to put some eyes and ears on, stand back and start the cut. Starting the automatic table feed. Start off with 10/1000ths of an inch. Do that cut easily. Depth of cut. Try 40 because the high freeze for a little bit. So here we are. This is a 1 3/16 inch depth of cut, 40/1000ths of an inch feed. The metal is 1018, which is gummy, so the back side of the chip is kind of rough, but actually the surface here, even though this is very much just a roughing cutter, is really not too bad. A little bit of wave to it, but for roughing, perfectly acceptable. So this shows that you can get quite a bit of force out of these. This machine is perfectly capable of breaking a 1-inch tool bit if you let chatter build up or not pay attention to what you're doing. So it's certainly a machine to be respected. Enjoy yourselves in your shops and be safe.